Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about the inverse functions. So we're going to learn about what is the inverse function, in which situation the inverse of a function exists, and also how to find the inverse function. So before we proceed, so let us redefine what was a function again. So the function again is the map between the two sets, so from the domain to the range. So you can just understand this like, hey, you've got a domain with lots of items there, or the numbers, and you've got a range, another set of items, and the function is essentially takes one number from the domain and brings this to the range. Okay, for example, if the domain is going to be a vending machine with lots of items there, right? So it's going to be the vending machine and the range is going to be the prices, then the keyboard of the vending machine is going to be our function. So essentially here, if it is like the Fanta is there, if you just press the Fanta, so this function is going to give you the corresponding price of the Fanta. So this is going to be our function. So essentially you can understand the function again so as kind of a machine which takes as an input some x and it gives you some output y. And again, graphically, it means that you've got some x from the domain and you're going to find its corresponding y here from the range. And this arrow or this map, which corresponds the x and y, is called the function. So not any curve is a function. So for example, if you are given like x is equal to the y in the square is not a function, not a function. The problem is that, so if you would just draw a domain and a range, domain on the range. So where the domain is, so which value, so you're going to get the values for the x from the domain, and you're going to get the values for the y from the range. Now, if x is equal to the 4, so let's say I've got 4 here. So where I can go in the range? For example, I could just go to the 2, right? Because the 2 in a square is equal to the 4, okay? But the problem is that I can go to the minus 2 as well, right? So if I would just have the minus 2 here, so I can go to the minus 2 from the 4 as well. So if you would just think about as a computer, then we would just kind of stuck because you are find yourself in the 4 and you don't really know where you can go either to the 2, either to the minus 2. So this is not a function because you can go to the 2 destinations from the origin. So essentially more than one destination, 2 destinations. So at the same time, if you would just write down the function y is equal to the x in the square, and what you have here is again, so if you would just draw the domain on the range, so you can see here that you can go to the 4 in the range from x is equal to the minus 2 and x is equal to the plus 2. You can go from 2 points to the same point. So again, so just one destination. So this is again a valid function. So this is a function. And this curve, x is equal to the y in a square, is not a function. And please note that this is not a function because there are 2 destinations. So if you just find yourself here at this x, you can't really know to which y you need to go. There are 2 arrows there. So now, one of the ways to identify whether you've got a function or not, to just test this using so-called vertical line test. Vertical line test. So graphically, you can check this in this way. So any vertical line should intersect with the curve at most once. If this condition fulfills, then you've got a function. So let's try to draw this. So let's say in the case of x is equal to the y in the square. So let me draw this function first of all. So it's like a y-axis and x-axis. If I would just draw x is equal to the y in a square, it would be kind of a parabola which lies on the x-axis, like this, right? So we said that there's not a function because you can go to the two destinations from the domain, right? From the origin. And we can check this using the so-called vertical line test as well, because here, if you would just draw the vertical line here, at some point x is equal to the 4, for example. And then this vertical line is going to intersect with your curve at the 2 points. So essentially, at the y is equal to the 2, and at the y is equal to the minus 2. So that is why it's not a function, because we found at least one vertical line which intersects with the curve more than once. And again, so if you would just draw another function of the parabola, for example, like this one, which is essentially like so y is equal to the x plus 3 maybe in the square. So this point is going to be minus 3, right? This is the function because it doesn't matter where you draw your vertical line, it is always going to intersect with your curve at most once. For example, if you draw this here, no interaction, but if you draw here, there is only one time interaction. So this is how we are going to define the whether you are given a function or not. At the same time, not any function has its inverse. So whenever we say the inverse, it should just revert our original value. So let me just give you a couple of functions to just give you some insights about what we're looking for. So let's say the examples of the inverse functions. Examples of inverses. Okay, so let's say you're given f of x is equal to the x plus or minus 3, and g of x is x plus 3. Okay, uh, good. So these two functions are the inverses. Okay, so because let us do the domain and the range. Domain and the range for the f function. Okay, so you've got here, let's say 3, x is equal to the 3. So if you just plug this to the f function, where you go is to the 0. Y is equal to the 0. This is what does the f. At the same time, the g, so if I would just plug in x is equal to the 0 to the g, right? So essentially this is y. So you can go back to your original value. If you just substitute x to be equal to the 0 to the g, you would get here 3. Y is equal to the 3, right? So this is f and this is g of x, f of x. So you see, so you are getting your original value. So you used to have 3, right? If you apply the function, you will get a f. If you apply the inverse to the output of a function, you are going to get again your original value is 3. So this is what does it mean, the inverse functions. So now we are going to do a little bit more analysis on the existence of the inverse functions. So the definition of the inverse function analytically can be shown in this way. So the two functions. So let us write down the definition first of all. Definition. So two functions, f of x and g of x are the inverses if and only if f of g of x is equal to simply x. At the same time, g of f of x is also equal to x. We call this as a composite. Whenever you're going to plug in one of the functions into the another one, this operation is called the composition of the two functions. So essentially, the composition of these two operations should be equal to the x. So we can check this to our previous example. So let's say I've got f of x, and it was x minus 3, and g of x is x plus 3. If you would just substitute the g of x to here instead of x here, what you get? So f of g of x. So what you need to do is you need to look to this g of x as a symbol, right? So here, if you remember, f of x, where x is some symbol, is this symbol minus 3. And if you would just substitute this x with another symbol, g of x, then you need to do the same thing. So the symbol minus 3. So your symbol g of x minus 3. Now I'm going to just substitute the g of x with its value, which is x plus 3, right? And I need to subtract this minus 3, so it's going to be equal to the x. So this means that the g of x and f of x are the inverses. You can just denote this as f in the power of minus 1 of x is equal to g of x. So we call this as the inverse, the notation for the inverse. So now let's discuss, when does this inverse exist? So again, let me draw the function. So here, if you remember, the domain on the range, right? So you remember that, hey, a function, so a curve can be a function if there is only one destination. So whenever you found yourself on a certain point in the domain, you need to be able to go to another place, to the point from the range, in exactly one way. So essentially, if you've got here x, there should be only one arrow which brings you to the range, right? Now, at the same time, what does the inverse is that it brings you back from the range to the domain, right? This is what does the inverse of the function. And in this case, in this regard, we're going to define something which is called like a one-to-one functions, one-to-one functions, which essentially tells you that so for every two different values from the domain, there are two different values in the range. So one-to-one functions is that for any two x1 and x2 from the domain, so which are different, so x1 is not equal to the x2, there exist two values y1 and y2 from the range which are also not equal. So essentially, you can just go from x1 to the y1, and from x2 you can go to the y2, okay? And it works always, okay? And at the same time, so we've seen before, so let me give you an example of a non-one-to-one function. So I've got this function here, y is equal to x in the square. This is not a one-to-one function, because it doesn't fulfill this condition, right? So again, if you remember, the one-to-one function tells you that, hey, if you choose two different values from the domain, for example, minus 2 and 2, you need to have two different values, corresponding values, in the range, right? Always range, this is the domain. And which is not true here, because you see, so you can go to the 4 from the minus 2, and you can go to the 2 to the 4 from the 2 as well, right? Essentially, if you would just substitute 2 or minus 2 to here, you would always get a 4. You see, so for the two values, x1 and x2, which are not equal, you've got y1 and y2, which are equal. Okay, so this is what does it mean, the definition of the one-to-one function. And in this regard, it is really important for us to identify whether your function is one-to-one in order to identify the inverse, right? Because in this case, what does it mean, the inverse? The inverse means that you need to come back from the 4 to the domain, right? And if you remember, so if you find yourself in a point and you have two destinations from that point, then this can be a function, okay? So that is why if your function is not one-to-one, it means that two different points may refer to a single point in the range, it means that you cannot come back to your origin. So that is why if your function is not one-to-one, there is no inverse. So essentially for this function, there is no inverse. So only one-to-one functions may have the inverse. So how to identify whether your function is one-to-one? So how do we know? How do we know whether the function is one-to-one? Whether the function is one to 1. Well, we can do this using so-called the horizontal line test. Horizontal line test. So what does the horizontal line test tells you? That any horizontal line should intersect with your curve at most once. Horizontal line intersects with the curve at most once. And again, I would like to draw the coordinate system. I would like to draw the parabola. And if you remember, the parabola is not a one-to-one function, right? Because there exists this horizontal line, for example, which is going to intersect with a curve more than one. So for example, this horizontal line might be at the 4, so simply y is equal to the 4, and it may intersect this with this line at the 2 points, at the -2 and 2. So this curve is y is equal to the x in the square. At the same time, I can draw another function which is going to be the one-to-one function. So any line is a one-to-one function. For example, I can draw this line, right? And you see, so it doesn't matter where is the horizontal line, it's always going to intersect with this yellow curve at most once. So just using the horizontal line test, we can identify your function as one-to-one function or not. So now, if you're given the one-to-one function, how to find its inverse? So the guidelines or the algorithm of finding the inverse is the following. So the algorithm of finding the inverse. So the first of all, you need to check whether your function is one-to-one. Check whether your function is one-to-one. So you can do this, for example, check the one-to-one. Well, let me write this in a more accurate way. So check whether the curve or your function, the function is one-to-one. Right? So again, so one-to-one means that any vertical line and any horizontal line should intersect with your curve at most once. So second, if you're given the curve or function in the form of y is equal to the f of x, we call this like, hey, your function is explicitly expressed as a y. You need to express your function as the x is equal to some function of the y, or it might be another function, g of y, okay? And in the third step, what you need to do is just recall x and y with each other. So let's do an example to show you what I mean. So let's do an example. So let's say we're given the function f of x, which is 3x minus 5. Okay, so in order to find its inverse, first of all, I need to identify whether this is one-to-one. So this is one-to-one because this is the line, right? So the line was the slope 3, is always going to be a one-to-one function. If you want, I can draw its curve. Its curve is going to be, so it's going to intersect with the y at the point -5, right? Okay, at the point -5, it's going to intersect with this. So it's going to be some line like this. Okay, so it's going to be 3x minus 5. Obviously, it's a one-to-one function. So the first step is done. So in the second step, so if you're given your curve as a y is equal to the 3x minus 5, you need to find the x from here. So I'm going to put the 5 to the left-hand side. It's going to be y plus 5 is equal to the 3x. From here, if I can find the x, it's going to be y plus 5 over 3, right? In the step number 3, what we need to do is we need to just recall x as the y and y as the x. It's going to be y is equal to the x plus 5 over 3. It's going to be the inverse. And again, if your function is 3x minus 5, then its inverse is going to be equal to the x plus 5 over 3. So how we can check whether you found a correct inverse? So you can just substitute the inverse instead of x. So let's do this. So f inverse of x is going to be, so then again, just look to this f inverse of x just as a symbol. So what does your function? It just multiplies the symbol to the 3 and subtracts the 5. And if you just substitute the x symbol with another symbol, then it should do the same thing. So it should multiply the symbol to the 3 and subtract the 5. So it is going to be 3 times f inverse of x minus 5. So now I'm going to substitute the value of the f inverse. It is 3 times to the x plus 5 over 3 minus 5. You can just cancel this 3 with this 3. And what you have here is simply x. So it means that indeed these two functions are the inverses. So now let's explore a bit more about the domains and the ranges of the inverse functions. So let's say we are given an example of finding the range and the domain of the function. So let's say you're given a function f of x, right? So it means that here, okay, so f of x is given in the form of, let's say, x minus 3 divided to the x plus 2. Okay, so essentially this is the one-to-one function. So we can just check this by making the graph of this function, and we can create a graph using one of the graphical tools. But let's discuss how to find the inverse, right? Or how to find the domain. So the domain is what kind of values you can take for the x. What values you may assign for x. For example, you may assign x to be equal to 0, then in this case, f of x is equal to minus 3 over 2, right? So what you can't assign is that x is equal to the minus 2, because if you would just substitute this, what you get is simply minus 5 divided to the minus 2 plus 2, which is minus 5 divided to the 0, right? So at this stage, we don't know what is this value, so that is why this point cannot be in the range or in the domain, sorry. So we are going to define the domain of this function as all the real numbers except the minus 1, right? Or we can just define this in an interval way, so it's going to be from minus infinity to the minus 2 and from minus 2 to the infinity. Okay, so both of the definitions of the domain are correct. Now, if you would like to find a range, it's a bit more difficult, right? So it's always easier to find a domain than the range. And one of the ways to define the range would be to find the domain of its inverse, right? So do you remember this again? So if you just drew these two sets, so this is the domain and this is the range. So do you remember what does your function? It takes the x and brings you to the range, right? So the origin where your function is starting its path is called the domain, and where the destination is the range. And now for the inverse of this function, the origin is the range of your original function, and the destination of the inverse is the origin of your original matrix, or original function, sorry. Okay, cool. So I'm given this function, I need to find its inverse in order to figure out what is the range of the f of x. So let's do this. Y is equal to the x minus 3 divided to the x plus 2. You need to express the x from here. So we're essentially doing step number 2. So I'm going to multiply both of the parts to the x plus 2. So it's going to be yx plus 2y is equal to the x minus 3. If you would just multiply both of the parts as the x plus 2 here. So now what I have to do is I need to express this in terms of the x, right? So I'm going to put two x's in one side, y's to the another side. So yx minus x is equal to the minus 2y minus 3. If you take out the x from here, from the bracket, it's going to be y minus 1 is equal to the 2y minus 3. If you would just multiply both of the sides to the minus 1 over y minus 1, what you get here is yes, or let's multiply, let's divide both of the parts to the y minus 1. So what you get here is x is equal to the minus 2y minus 3 divided to y minus 1. You can just multiply both, so both of these ratios here. Minus 1 to the minus 1. If you do this, what you get here is x is equal to 2y plus 3 divided to the y minus 1. So in the step number 3, you need to just recall x as a y as a x. So it's going to be y is equal to the 2x plus 3 divided to the x minus 1. So this is the inverse of our original function, right? So can we define the domain for the inverse? Domain for the inverse is that all the points except the x is equal to the 1, right? And this is essentially going to be the range of f, okay? So let's define one more time. So the f of x is equal to x minus 3 divided to the x plus 2. Its inverse is equal to 2x plus 3 divided to the x minus 1. Okay, so the domain for our function, original function, domain for this function is all the points except the x is equal to the minus 2. I'm just going to minus 2 here. Okay, and at the same time, domain for its inverse is all the points except the point 1. At the same time, the range of the original function is the same as the domain of its inverse. It's all the point except the 1. And the range of the inverse is the domain of the original function. It's all the points except the minus 2. So you see, so whether you're given the inverse or the function itself, so it's always easier to figure out what is the domain rather than the range. And usually we find a range by just finding the inverse of a function. Well, in this lecture, we've discussed about how to identify the functions using so-called vertical line test, how to identify whether your function is one-to-one using so-called horizontal line test, and also we've discussed about the algorithm of finding the inverse of a function, right? And we can always check whether you've got a function or not by just putting this into, by just finding the composition of your functions. So thank you very much for your attention. Hopefully this was helpful.